Hey, what's going on, y'all? It's your boy Algebra coming to you live and direct from the studio. This studio in particular is called the dining room of my house. Got my homeboy, little young Averick Reed upstairs, chilling, probably sleep right now. Gonna have to change his diaper in a minute. But until then, you got my undivided attention. I want to talk to you about word problems today. Word problems in particular. Uh, don't have to be difficult. A lot of people see a story, they don't recognize the numbers in it right away. They don't recognize that I'm having you solve a simple equation, and it starts to make you freak out a little bit. What I'm going to try to do today is help you identify the key ingredients to these word problems so that you don't really have to do as nearly as much work as what you thought beforehand. Let's talk about keywords for a second. The key words are their major clues. These are the things that are going to help you identify what is actually happening mathematically. Keywords, the ones that you learned a long time ago, were stuff like plus, minus, times. It's not really a good one for divided by. But what I think you're going to see more often than not is the word split. Split is a word that absolutely means division, just like times means multiply. You're going to see words or phrases that lead you to understanding things within a particular story problem. I might say subtracted from. It's obvious that you're talking about subtraction, but the word from means that it has to come second. Did you realize that? The word from lets you know that something already existed earlier in the problem. Similarly, this could be something like added to. Having that extra piece is letting you know that something else had to exist. I could say something like 21% of a number. Again, that's telling you that there's something already there that you need to be aware of. So anytime that you see this kind of situational um, guaranteeing you that there's a second piece to this equation, froms, tos, ofs, you need to make sure that you understand that that number is coming second. Whatever it just said has to be the second piece of your equation. 21 is subtracted from x. That means it's x minus 21. 36 is added to 11. 36 is being added at the end of the 11. 11 plus 36. 21 is 17% of what? That means that the 21 is over 100 and you're trying to figure out what it's out of. Okay? So again, these key words, they can be singular such as plus, minus, times, split, but you could have things where you're setting up a double, a two-piece situation. Other words that you need to be aware of in a story problem. You're going to see sum. You're going to see difference. You're going to see product. You're going to see quotient. Those four words, you should automatically know which ones they are. Your sum and your difference, those are the answers to addition and subtraction respectively. Product is the answer to a multiplication problem. Quotient is the answer to a division problem. Okay? So depending upon what I give you in any particular instance, you should know exactly what is being asked of you. An additional word that you have heard me use during class, but I haven't asked you to do it yourself, is quantity. Quantity means parentheses. If I say something like 3 times the quantity of x plus 5, That means 3 times parentheses x plus 5. That means you're going to have to do a distributive property. Hopefully at this point you're starting to recognize the fact that you've been using these words a lot. You've been talking about this stuff quite often. We just need to start to use it contextually. We need to know where the problems came from and understand how to dissect those stories. Let's go ahead and do some examples. Passed out to you at this point, you should have received a story problem packet. Has a whole bunch of problems. I'm going to do all of the left column, so that's all of the odd questions with you. All the evens are yours to practice. Pretty much every problem has an exact match from one column to the next. So if you want to do an example with me, then pause the video, do it yourself. You'll be able to check your answers as we go, because I'll just pop the answers up for the next question. At this point, I'm going to pause, get myself together, get myself ready, and now we're going to be ready to go. All right, so my homegirl Gabriella enlarged the size of a painting to a width of 4 inches. What is the new height if it was originally 3 inches tall and 2 inches wide? So what you need to understand is that we're talking about the word enlarged here. When you see this word, you should automatically think of proportion. That is a key word for you. Proportion. In other words, that means 2 equal fractions. We talked about proportions earlier this year, and the best way to solve them is to cross multiply. But understanding how to set this up is a huge and major important piece. We're going to set up 2 different situations. One, we're going to call it the original. The other one, we're going to call it the new size. In the original, there was a height and there was a width. Same things in the new. So what we're trying to do is, because we're talking about a proportion, we know that these 2 fractions are going to be equal. The original height was 3. It was 2 inches wide. The new height, I don't know what that is, but it's going to be 4 inches wide. Boom, bam, you just set up an equation for yourself to solve. So in that last question, you notice I just set it up and then I stopped. That's all I really cared about at this particular point in time. I need you to be able to set these equations up. You already know how to solve it. I don't have any problem believing that. Every single one of you has shown over the past 4 months that you know how to solve an equation. I need you to be able to set up an equation. I need you to be able to make it now. Because where we're headed is to take those same problems that had 2 variables in them, 2 equations in them, 2 situations in them at the same time. You need to be able to read that from a story problem. Oh, we're starting off so slow because we're going to end up fast. Question number 3 says, 4-foot tall car is standing next to a ladder and casts a 1-foot shadow. The ladder is 16 feet tall. I want to know how long is the shadow going to be at that point in time. Okay, so main idea is you should probably draw a picture. I see a car and a shadow. So if there's a ladder, there's going to be a shadow. These 2 things, again, they are proportional. Because I'm saying it's the same situation. You know, the sun hasn't moved. It's creating a shadow in the same direction. We just need to be able to identify the pieces the same way as we did in that previous question. If this is 4 and there's a 1, this is a 16. We need to figure out how long the shadow is. That to me looks like a proportion. 4 over 1 equals 16 over x. Cross multiply and solve. When you start to see things that are being compared directly one thing to another, like a simile in the English class, or like I can't even remember the word. It's not a metaphor. It's an analogy. One of those things where it's the is to and the as to and all that stuff with all the extra dots. I may be dating myself at this point in time because y'all probably don't know what I'm talking about. whenever you see a situation like that, it's telling you a proportion. Okay? So if nothing has changed except for sizes, you need to see two equal fractions. You're basically just trying to reduce. Let's keep it rolling. All right, so in this particular section, it gets a little bit different. I asked you to find the selling price of each item, and I told you I was going to do all the odds. So notice the information I'm putting onto the screen is with regards to number 5, not question number 4. It said Natalie spent half. That seems important. Let me ask you a question real quick. When you spend money, is that positive or is that negative? This is a negative for the 1/2. In order to earn extra money, her parents let her weed the garden for $10. I see the word earn more. That's talking about adding. One of the most important key words that I did not highlight for you is the fact that we need to always have an equal sign. And in this particular situation, that equal sign is denoted by the word is. Sure, you may see is in different parts of a story, but the part that comes afterwards, the subject after the word is, or the subject that is directly before that powerful word is always going to tell you that you have an equal sign. So here we go. I see a negative x over 2. And somebody says, well, how did you get the over 2? Well, isn't half just mean over 2? Doesn't that just mean that you're dividing something by 2? Yes, it does. The negative is because we're spending money. The X is because I have no idea how much money she got for her allowance. So then it asked me to add $10 for weeding the garden. Plus 10, we said she earns more. That sounds like addition. Finally, we get to the last part of this equation. It is 13. There's an equation. There's a fraction involved in this equation. That's not a huge deal to us. We know how to deal with fractions. We just needed to make sure we set it up and got to a point where we could do something. Any questions? I didn't think so. Let's talk about number 7. Psych. I'm going to pause my screen again and give you a whole new video for the rest of the assignment. Peace.